Okay, so this question here, Gwenda enjoys running. She keeps a record of her run each day this week. Okay, so there's the distances and then there's the time she spent running. Last week, her average speed for the week was 9.6 kilometers per hour. Calculate Gwenda's percentage improvement in her average speed from last week to this week. So we need to get the average speed for this week. Last week was 9.6 kilometers per hour, yeah? That was last week's speed. So this week's, then, we need to work out the average speed in order to work out this percentage improvement. So to get average speed, right, you need the total distance and the total time. You need to work them out. So total distance, you need to add all these together here, okay? So we can write that down. It's important you show your workings. So obviously it's a QWC question. So, we write all of these distances down here. And, in any question, really, you want to write these down so you can show your workings out. So we add these up on a calculator. And you get 31.2 kilometers. Okay. You also need to work out the total time. So add the times up. So 26 plus 31 plus 12 plus 35 plus 40 plus 14 plus 22. Get 118. That's 180 minutes. Okay. So when you work out the average speed, of course, you want this in kilometers per hour, yes? We've got kilometers here, so you want this in terms of hours. So that would be 3 hours, wouldn't it? If you think about it, because 60 minutes an hour, so 3 hours there. So the average speed then is the total distance divided by the total time. Okay, so total distance is 31.2, total time is 3, so you work that out. Distance over time, isn't it? That's what speed is. So we get 10.4 kilometers per hour. Okay, so that's what the speed is for this week. Now then it says calculate the percentage improvement. How is it improved? Now to get percentage improvement, remember, use this formula. So the percentage improvement is equal to the difference that it's improved by, divide by the original, divide by last week's, times then by 100 to change it into percentage. So the difference will be, 10.4 this week, 9.6 last week. So 10.4, take away 9.6, divide then by the original, last week's, which was 9.6, times by 100. So we get our answer out there. So, you can do that on one go on your calculator. And you get, I should change that to 9.6, not 96. You get 8.3%. Okay, rounded there to one decimal place. Part B then, the diagram shows the cross section of one part of her run. Okay, calculate the angle of elevation of the road. Now the angle of elevation is this here, yeah, this angle here. So using trigonometry, that's the opposite, isn't it? That's your adjacent, that's your hypotenuse. Okay. Opposite the angle, adjacent to hypotenuse, opposite the right angle. So in this case, we're going to use O and A, okay, because we know O and A. So O and A, SOHCAHTOA, O and A will be the tan, won't it? The tan. So tan X equals OA 200 over 1600, okay? And then to get X, then, of course, to get the angle, you do then take the tan over the other side, so you do tan to the minus 1, so on your calculator you do shift tan, and you get, type that in wrong about, so you get the angle then, which is 7.1 degrees, right? So we go to one decimal place. So it says then, part C, Gwenda runs on another section of uneven road from A to B. The rise in this section is 300, so you're talking about the rise, the vertical. And the angle of elevation of B from A is 10. So angle of elevation is this here, 10 degrees. Calculate an estimate for how far Gwenda has run. State any assumption you've made. Okay, so estimate how far she's run. We're interested in this here, yeah? So we'll take it as a triangle. And if we take it as a triangle, that's going to be O, isn't it? Opposite that angle there. And this is going to be a hypotenuse. And this is your adjacent. Now, again, we're going to use SOHCAHTOA. Okay, now O we've got, okay, and we want to work out H. So O and H be sine, okay? So sine 10 degrees equals opposite, which is 300, over then the hypotenuse, okay? Now the hypotenuse then is what we want to work out, okay? Which is on the bottom here. So if it's on the bottom, we need to take that up. We need to swap them, don't we? 300 divided by sine 10, and we get our hypotenuse out. Okay, so we get that out to be 1,727.6 meters. Okay, and the assumption we made, well, the assumption we made was, of course, this road is flat, isn't it? Okay, so we've assumed road is flat. We've assumed it's flat so that we could actually treat this as a triangle, yeah? Right angle triangle. Obviously, it's not flat in practice. It's bumpy, it's uneven, okay? So it's not really, you can't really use SOHCAHTOA then, can't you? But because it's so close to being flat, it's so close to being a right angle triangle, this is actually pretty good, isn't it? Pretty good to work where it's going to be. What is the impact of your assumption on your answer? Well, actually, the answer then is, this answer here is actually probably a bit shorter than what the run actually is. So you could say, look, the run is probably longer. Okay, so the run is probably longer. Okay, because the road is actually uneven, which means slightly longer than the flat straight line that we've got here.